Hello everyone. Today I am going to discuss about errors in the pharmaceutical analysis. Myself, Navdha Soni, Assistant Professor in the Department of Quality Assurance at LG Institute of Pharmacy, Ahmedabad. So let's start with errors in the pharmaceutical analysis. These are the table of content containing introduction, types of error, accuracy, precision, and minimization of systemic error. Let's start with introduction. In daily life, we are using word error, means something is going wrong or something is wrong. Okay. But in the case of pharmaceutical analysis, error is the difference between the true result or accepted result and the measured result or measured value. If the error in the analysis is large, serious consequences may result, as reliability, reproducibility, and accuracy are the basis of analytical chemistry. A patient may undergo expensive and even dangerous medical treatment based on the incorrect laboratory result or incorrect laboratory practice because of an analytical error. The difference between the experimental value and true value is termed as absolute error. For an example, in the book, they have given a endpoint is 9 ml. But while you are performing titration, the result is 8.9 ml or 8.8 ml. So the difference between 9 ml and 8.8 to 8.9 ml, that means that 0.1 to 0.2 ml is absolute error. It may be negative or positive. It may be possible that 9.1 and 8.9. So it may be positive or negative. Here error is measured mean value minus true value upon true value. These are the two types of error: determinate error and indeterminate error. Determinate error is also called as systemic error, while indeterminate error is called as random error. Name itself suggests determinate error, it means it can be determined or it can be easily corrected, while in the case of indeterminate error, it cannot be determined or it cannot be easily corrected. So, first is determinate error or systemic error. They are caused by the faults in analytical procedure. If we are using any wrong analytical procedure, it will directly lead to the systemic error. Or instruments which are used in the analysis. If faulty instrument if we are using faulty instrument, it will lead to systemic error. This means the fault in the system. Okay. This determinate error are systemic errors, and that is they are not random. As the name indicates, that the cause of the cause of this type of error may be found out and then either avoided or corrected. A determinate error may cause analytical results produced by the method to be always too high. Another determinate error may render all results too low. Sometimes the error remains constant. All results are too high or too low by the same amount. Determinate error can be additive or they can be multiplicative. It depends on the error and how it entered into the calculation of the final result. They could be the result of incorrectly calibrated balance. I'm telling one example. If the balance is set so that the 0 point is 0.5, the balance is showing 0, but the actual weight on that balance, that is 0.5. Okay. All masses determined by this balance will be 0.5 milligram too high. If this balance was used to weigh any standard solution or any standard material in the laboratory, the solution concentration will be erroneously high, and all the results obtained using this standard solution be erroneously high. The error is reported as the absolute error, and the absolute value is the difference between the true value and measured value. The measured mean value minus true value is equals to absolute value or absolute error. Determinate error may arise from some faulty step in the analytical process. The faulty step is repeated every time the determination is performed. Whether the sample is analyzed 5 times or 50 times, the results may agree with each other but differ widely from the true answer or true value. Systemic error is under the control of the analyte, means it is corrected by the analyst. How are the determinate error identified and corrected? One thing is one thing should be done, that is error should be corrected. Okay, but how it can be identified and corrected? One is to analyze the sample by completely different analytical procedure. If we are using one analytical procedure, so error, if error is seen, so one we have to analyze the sample by different analytical procedure. That is known to involve no systemic error. Such methods are often called as standard methods. They have given in the various standard books like Pharmacopoeia. Okay, they have been evaluated extensively by many laboratories and shown to be precise and accurate. If the results from two analytical methods agrees, it is reasonable to assume that both analytical procedures are free from determinate error. And another method is run several analyses to reference material of known accepted concentration of analyte, and the difference between the known concentration and that measured of analysis should reveal the error. In second method, if any error is seen or any error occurs, one thing should be done, that is analysis of standard component. The concentration of standard component and our sample should be matched. Okay. This determinate error can arise from uncalibrated balance. We have seen the example of balance. Okay. Improperly calibrated volumetric flask or any other glassware, volumetric flask, pipette, burette. For an example, if I'm measuring any liquid, in particular pipette, but pipette is not calibrated, so when I am taking 10 ml of solution, it is not 10 ml, it is higher or lower than the 10 ml. Okay, so ultimately it will lead to the faulty result. So improper calibrated volumetric flask, pipette, burette or any other glassware. Malfunctioning of instrument. If instrument is not proper calibrated or maintained, it will lead to faulty results. For an example, UV spectrophotometer is not properly calibrated, so wavelength fluctuation is there. So if wavelength fluctuation ultimately directly affect to the actual result. Impure chemicals. If I am using 90% of alcohol, but alcohol is contaminated or impure, it will directly lead to the faulty result. Incorrect analytical procedure. But obvious, if procedure is not proper, so result may be vary. And uh, and most obvious, that is error of analyst. If analyst is not proper trained or well educated, it will be very dangerous. Analyst errors, they may be result of inexperience, insufficient training. An analyst may use instrument incorrectly, perhaps by placing the sample in the instrument incorrectly each time. It means the analyst, if analyst doing a experiment, they he or she should be well experienced and proper training. They have been given proper training. Setting the instrument to the wrong condition for analysis, these are the analyst error. Okay, misreading a meniscus in the volumetric flask, high or low, means when you are observing the meniscus, upper meniscus and lower meniscus. Okay, so misreading in the meniscus, it will lead to the error. Operational and personal error, what is it? These are due to the factors for which the individual analyst is responsible and are most connected with the method or procedure. They form part of the personal equation of observer. Examples are mechanical loss of materials in various steps of analysis, underwashing or overwashing of precipitates, ignition of PPTs at incorrect temperature. Let me give one example. If um, if in if in the standard book, for an example, in the pharmacopoeia, they have mentioned the product should be dried at in the air only. Means the drying procedure will be only in air. But the analyst is putting product into the oven. So ultimately, the component the component maybe active component decomposed. Okay, so these are the operational and personal error. Some analysts are unable to judge color changes sharply in visual titration. uh, you know that when we are doing titration, the color changes is colorless to pink. But what kind of pink? Light pink, dark pink, what kind of pink? So the color judgment is most important. Analysts should know what kind of color is required for the perfect result. So some analysts are unable to judge the color changes sharply in visual titration, which may result in the slight overlapping of the endpoint. Some other analyst related errors like carelessness, called transcription error, that is copying the wrong information into the lab notebook or onto the label. Wrong information they found it on internet or any other sources and directly copying from that particular source, it will directly affect to our product or ultimately our result. Proper training and experience and detailed on the part of the analyst can correct the types of error. Means proper training and education is required to correct this type of error. Reagents and instruments. As we said earlier, if we are using contaminated reagents or uncalibrated instrument, it will directly affect the result. Contaminated or decomposed reagent can cause determinate error. Prepared reagent may also be improperly labeled. If we are using prepared reagent, it should be checked that these reagents are actually that kind of reagent or not. Okay, so prepared reagent may also be improperly labeled. Impurities in the reagents may interfere with the determination of the analyte, especially at the ppm level, parts per million level or below. Numerous errors involving instrumentation are possible, including faulty construction of balance, incorrect instrument alignment, incorrect wavelength settings, and use of uncalibrated or improperly calibrated weight. So these are the possible consequences of error. These problems can be eliminated by systemic procedure to check the instrument setting and operation before use. So we have to check every time this all the these all the these are the problems which can be corrected or not. So if we have to check this all the parameters. This problem can be eliminated by systemic procedures to check the instrument setting and operation before use. Such procedures are called as SOP, that is Standard Operating Procedure. There should be a written SOP for each instrument and each analytical method used in the laboratory. Next is indeterminate error or random error. It cannot be pinpointed to any specific well-defined reason. In earlier, that means in the determinate error, well-defined reasons means by this reason this error is occurred. But here it is not possible. So pinpointed to any specific well-defined reason cannot be pinpointed. They are random in nature and take place in several successive measurements performed by the same analyst under the same condition and identical experimental parameters. Sources of random error include limitation of reading balance, electrical noise in the instrument, and vibration caused by the building by heavy vehicular trafficking, which are beyond anyone's control. While in the case of determinate error, the analyst can be controlled, okay, or the error can be controlled by the analyst, but here it cannot be possible. For example, a balance that can measure only 0.001 gram cannot distinguish between two samples when masses of 1.0151 and 1.0149 gram. In one case, the measured mass is low, and in other case it is high. Okay, it cannot be distinguished by the electrical balance. Accuracy. Accurate result. In general term, we are using he or she is very accurate. Accurate means a proper measured amount, means true value. It is very near to true value. Okay, an accurate result is the one which matches very nearly with true value of the measured amount. Accuracy is inversely proportional to the error, that is, greater the accuracy, smaller the error. Precision. Agreement among the cluster of experimental results, however, it does not imply anything with respect to their relation to the true value. Precision designates reproducibility of the measurement, while accuracy, the correctness of the measurement. So difference between accuracy and precision is clear. These are the various these are the various steps for the minimization of systemic error. First is calibration of instrument and apparatus or any other glassware and applying necessary corrections. Instruments commonly used in the lab, such as the spectrophotometer, electrical balance, etc., must be calibrated before the use. Pipettes, burettes, and other glassware must be calibrated. Analysis of standard sample means if you are using any kind of chemical or reagent, same procedure should be done with standard sample. So the difference we can see the difference between them. Independent method of analysis, performing a parallel control determination and blank determination. So these are the various factors for the various steps for the minimization of systemic error. In the GTU examination, they can be asked as what is error and explain types of error. and sometimes they can ask like what is error, differentiate determinate and indeterminate error, and what are the steps for the minimization of error. Thank you. Thank you for watching me. And one thing that is, please subscribe our channel, that is Pharma Ignite, to get updated knowledge. Thank you.